I love these, these events. They really are a fantastic opportunity for us to learn from each other. And I really appreciate CLT's role in pulling all of this together. So let's give them a round of applause for the work they've been doing. It certainly is terrific. Okay. I have the pleasure of introducing Provost Carol Simpson. Dr. Simpson joined ODU in January of 2008 as our Provost and Vice President for Academic Affairs and Professor of Ocean, Earth, and Atmospheric Sciences. She obtained her PhD in geology from the ETH Zurich in Switzerland and has taught on the faculty of Virginia Tech, Johns Hopkins, and Boston University, among others. Before joining ODU, she served as a Provost and Senior Vice President at Worcester Polytech in Worcester, Massachusetts, and prior to that, she was Professor of Earth Sciences and Associate Provost for Research and Graduate Education at Boston University. Dr. Simpson has authored over 50 refereed publications and 80 conference papers. She's an elected fellow of the Geological Society of America and has served as a program director at the National Science Foundation, on the National Solar Observatory Oversight Committee of the Association of Universities for Research in Astronomy. Wow. And also on numerous federal and academic review panels and editorial boards. She currently serves on the board of the Cooperating Hampton Roads Organization for Minorities in Engineering. That's a brief snapshot of her academic credentials. What I've learned about her by working with her is that she's a dedicated, hardworking, and passionate leader, scientist, researcher, teacher, and advocate for the university and for its faculty, its staff, and its mission. Among her many goals for this campus is the expansion of our Center for Learning Technologies toward a broader Center for Learning and Teaching in support of quality educational practices, retention, mentorship, and sharing of best practices. So she certainly is a leader after our own hearts in this room. Without further ado, I'll introduce Provost Carol Simpson.
Well, thank you and good morning. It's great to be here. I guess I'm the one who's standing between you and lunch, so I'll try and be to the point here. A couple of things I wanted to talk about today, because I know some of you are familiar with the university's strategic plan, and some of you helped write it, so that you really do know it very well, and others of you perhaps not so much. But there are a few things in the context of teaching and learning that I did want to emphasize. First of all, we made a great point of making our goal number one in the strategic plan, providing the students with the tools to succeed. And that sounds wonderful, and it's a great kind of buzz line, but what exactly does that mean? And who are our students anyway? We're dealing with a group of students now who are very different from the students that I was among when I grew up, that I taught 10 years ago. It's common to say that students often come to universities now underprepared. It's a word we'll hear a lot. Are they underprepared, or are they just differently prepared? They're every bit as bright as they were before. I mean, nothing drastic's happened to the human race that suddenly this generation of students has gone stupid. I mean, they're all equally bright as they were before, on average. And yet they don't succeed as well when they come in. And that's partly because I believe they are very isolated. They've never been more connected. They've never been more isolated. Used to be that you'd see groups of students walking around the campus talking to one another after class. Now they'll be on a cell phone, or they'll be doing their email, and I've been known to do, sort of texting while walking. I mean, I don't text while driving, but I do occasionally, text while walking. They are very isolated in their electronic worlds. And so part of the difference is that they're not used to the interaction that we are and that we expect from them. They are used to very slick visuals. They're used to docudramas. They know all about the history of the world from the History Channel. They know all about the geography of the world from the National Geographic. They know all about the science from Nova and Discovery. And to be honest, there's a lot of extremely good stuff in those documentaries or docudramas that are out there. But do they really know anything, our students? They don't have to memorize. Why memorize when you can Google? I mean, I've even found myself Googling the answers to crosswords. Then I don't actually know who wrote a particular phrase, and I think, no, this isn't right. This is not the way it's supposed to be. So how do we engage them in learning when they come out of a world that's so different from the one that we all grew up in? I think, looking around, there's some young faculty here, but still, I mean, the world has changed in the last 10, 15 years. And what do we want them to know? Do we want them to know their math by rote? Do we want them to be able to write English as it was written in the 20th century? They text now. We find that somewhat alarming when it creeps into essays. But we can read what they're saying. We know what they've said. We just choose not to like it. Not suggesting that we necessarily, change around our English 101 classes so that we have all of our essays written in text, although that would be an interesting too. And I've seen some excellent poetry that's been written in text style in recent years. No, what we want them to do now is to be more engaged with the critical thinking, to take the information, Google it if you must, bring it to class and then discuss it, then analyze it, then say what's wrong with this, what's missing, where are the critical pieces, what is it that we know for fact, that versus what we think we know, or that we'd like to think we knew. And those are the kinds of things that are very difficult to kind of grasp, and they're also very difficult to measure. And in the world that we're in now, where there's lots of assessment, lots of measurement, how do we measure when a student really has grasped critical thinking and can take lists of information and turn them into something meaningful? Well, one way that I think we can begin to approach that, and it's by no means foolproof, is to really get the students more engaged in real-life experiences, even at the introductory level. To really start out at that intro level saying, here is why we feel that you need to know some basic math and some basic chemistry and some basic physics and some basic English and some basic social skills. I do that a little bit with one of my classes. I teach an introductory class in the fall for freshmen called Natural Disasters. It's designed for freshmen, so when the expectations are not terribly high yet, but I put all of the different skill sets that they'll need into the class right from the beginning. And we start by looking at the way the Earth works. So we spend a couple of weeks on just the inner structure of the Earth and plate tectonics, and make sure that they have actually absorbed what they've seen on NOVA and Discovery Channel, and that they do understand what the Ring of Fire is and what it's not. And then we go on and we start by looking at volcanoes. But I could stand there and I could lecture to them about volcanoes, or I could show them pretty pictures of volcanoes, and in fact I will in the next class show them a couple of video clips of volcanoes in the process of erupting. After all, Iceland has given us a wonderful example now of the consequences of a volcano erupting in an inconvenient place. Questions that will come up, I know, will be, are there more volcanoes and earthquakes happening now than there were, a year ago, 10 years ago? And the answer is no. It's just that it happens to be inconvenient. And that one's got in our way, and might yet get in my way, because I'm supposed to go visit my grandson in Spain at the Memorial Weekend. So we'll see if we get there, or if I get back. But for them, then, I'm able to say, here's something that is relevant to you to understand how a volcano works. More than that, to understand the social consequences of that. And so we will begin by heading off. I'll send them off on Google. I'll say, go find me your favorite volcano. No, you may not use the one from Iceland, because we're going to work on that one anyway, but go find another one that's erupted in the last decade and that's had an equally large output of volcanic material. Well, they'll come up with, I'll let them stretch the time a little bit, because some of them are obscure volcanoes. So I'll let them go back, and they'll probably come up with Pinatubo. And they'll, some will try to have Krakatoa, and I'll say, no, we'll do that one later, because we'll go on and do supervolcanoes and Yellowstone. And, things, that they've heard about, but again, not a very good feeling for. And then we'll start to analyze the data. How do we know how frequently these go off? And how will we measure that? And this is where rates come in, and frequency. And before they know it, they've learned some physics, and they've learned some math, or they've revised some math and physics that they didn't know. And we do some chemistry, because some volcanoes explode and others don't. Why is that? Well, it's all about the chemistry. And so we'll do some basic chemistry. And what I then will do after a week or two of that is to sort of say, now let's have a look at what we've been looking at, not just from a factual point of view, but in terms of the skill sets that you're beginning to develop. And if you're going to go on to do more things in the natural sciences, then you will need, a much higher level of math than we just looked at, and a much deeper understanding of chemistry. But they begin to see why they need to know these things, which is one of the basic questions they have. And I consider that part of providing the students with the tools to succeed, because the tools to succeed are in their hands as well as ours. They have to come at least halfway towards us. We can't go all the way towards them. Part of the role of the CLT in all of this, and Andy alluded to it earlier, is to really help with faculty development and beginning to work with students in terms of developing pedagogical models that they can work with, and to get them, the students, involved and engaged in lots of different ways. What works for me in a natural disasters class won't necessarily work for somebody in a different area. It won't necessarily work in health sciences, won't necessarily work in engineering, different techniques. And one thing that we have done, and I thank Alison and Mohammed in particular for their work, is last year they put together an excellent series of the Provost Conversations on Teaching and Learning, where we invited faculty that are known to be good teachers by the dint of having got awards to come and talk about some of the techniques that they've used successfully to engage students in the classroom. And we'll continue that this coming fall, except we'll be working more in the realm of advising, where advising fits into the whole area of teaching and learning. Because to me, advising is not scheduling, that's a different game. This is advising the students, getting the right match, getting the students' skill sets, such as they have, and their interest and the talent that they will have, but maybe unexplored, and getting them in the right place for their future. The expanded role of the Center for Learning Technologies, then, is the vision is to turn it into the Center for Learning and Teaching Excellence. So it'll be learning and teaching rather than learning technologies. The technology is a big part of that, but it's not the only part. The approach that we use with different technologies could be equally well done if we're working just one-on-one in the classroom without any visual aids or without any video clips, whether we're delivering it at distance or not.